we learn under a curve. And, hey, all right, so the real cool thing that we're going to learn next. So we found area under a curve. And we basically found that the area under the curve was where you made a bunch of little rectangles and found all those areas of all those rectangles. And those rectangles eventually got so small that they were basically a line. Now, if you took that line at any point, so let's say on this shape here, I took the line right here, and I rotated it 360 degrees about the x-axis, it would make a perfect circle. And we could find the area of that circle. Then connecting to an idea we already know, for example, you already know that, I should make this one dotted. There we go. That's not very dotted nice. If you wanted to find the volume of a cylinder, it's just the area of the bottom, which is a circle, multiplied by its height. So if we took the area of one of these rectangles when it was infinitesimally small, basically like a radius, rotated it 360 degrees, made a circle, and did that all the way along from point A to point B, we would then add all of those little circles together and get the volume of any shape that we want. So what's really cool here is that's an interesting shape. But if you do the area between two curves, another thing that we did yesterday, and rotate it 360 degrees, you could get shapes like this, like a bell. And you could find the volume of a bell through simple but complex calculus, right? We're doing complex things right now. The ideas are complex, but the actual mathematics is not that bad. So how do we find the area? It is just pi times the radius, and the radius will be whatever the value of f of x is at that point, squared, because a circle is pi r squared. And then you would subtract pi r squared, pi function squared, from the second one. Then if we integrate this from point A to point B, we actually get the volume of that shape. Well, yeah, it depends how you look at it. If you take, here is an example of a really weird shape in mathematics. Okay? Gabriel's horn. This isn't in your notes. It's basically taking, I believe it's the 1 over x graph, just this part of it. And in fact, you only have to start there. If you rotated that 360 degrees, can you see that you would get this shape? And since there is an asymptote here, it goes on forever. And it's a paradoxical shape because it has an infinite surface area, and yet it has a finite volume, which should make your head blow up a little bit, because that means you could fill it full of paint, and that paint would touch the entire inside. But if you pulled the paint out to try to paint the outside, you'd run out. There's no end to it, but there's also no end to its volume. But you can find the value for one of them, but not for the other. This is why it is a infinite surface area but finite volume. Anyways, similar. So your formula is just the integral from a to b. Your function gets squared because you think of pi r squared, and your function is your radius. And you can pull the pi out in front. Yeah, f of x squared minus g of x squared. Yeah. It wouldn't be the two of them together, then squared. Yeah. So as we have here, I have it at the beginning part, it's f of x squared minus g of x squared. So sometimes you see it with the pi on the inside, and sometimes the function's written with a y. So just to be prepared for different forms of the same thing. So if you can graph the original function, right, then rotate it. Here, practice graphing. I'll show you how to practice drawing these. So first of all, you would draw x cubed. So here is my x cubed graph. I've got the point 1, 1, and 2, 8. You take those same 2 points, 1, 1, you draw them below. So there's 1, -1 and 2, -8. And you draw a three-dimensional circle, which is kind of like an oval, through this one. And same thing through this one. Well, you're going to make your shape three-dimensional in the end. I'm expecting you to attempt them. On how good your drawing is? No, this is not an art class. If it says draw a diagram, then you will. If it doesn't, then you would not have to. It's possible. Okay. Practice your drawings. Go to art class. But what I would suggest when you draw it, because drawing it sometimes can be atrocious, when you go to color it in, oh, I like to use crayons. Yes. I choose a different color. Here we go, pulling out crayons. Whatever the end circle is, color that in with one color, and then choose a different color for the sides. Crayons would be wonderful, yes. It's like, so there is some coloring skills for you. But I find if you color the main circle that you would be showing in one different color, you're going to be able to see the three-dimensional shape better. Can you kind of picture it now as a three-dimensional shape? And you're like, no, Mr. JR, your drawing's still terrible. Okay. So now, to solve for it, we just need the integral from 1 to 2. Our original function was x cubed. It's going to get squared. And there's a pi that you can bring out in front. And the pi could be inside, but for calculations, it's nice to just multiply everything by pi in the end. So the inside function is x to the 6th. That's an easy integral. You'll get x to the 7 over 7. Plug in 2, plug in 1, subtract them. So once again, the concept is amazing. The mathematics isn't hard. What we just calculated is amazing. To think that we can calculate the shape of anything that can be bounded by a curve that we know. So again, we'll practice drawing together. So first of all, you need to know how to draw the square root of x minus 1. That's your square root graph. Shifted 1 to the right. Looks like this. We're going to look at it from 1 to 5. So you could plot on here, if you plugged in 5, you'd have the point 5, 2. Similarly, same distance below, you would have now between these 2 points, I can make a circle like this. Ooh, pull out my crayons. I'm going to go, oh yes. Just make anybody else think of like a ham. No. So there we have the visual for it. Pretty much the same. So now we can find how much ham we actually have. One ham. Question solved.
I guess that is an application. Take out all the meat. How much water can you fit inside of it? Is there anything?
Oh, a very, very useful application. What's really nice about this equation is once you square the square root, again, you have a really easy integral to find. That's right. So the integral of x is just x squared over 2. The integral of minus 1 is just minus x. Plug in 5, plug in 1. And you get your final answer, 8 pi units cubed. So that means 1 ham has the approximate same volume as 8 pies. No. I think it works. I shouldn't have said anything. I'm making a note to myself to avoid naming shapes and avoid colors. You didn't finish? I can go back. Sorry. Watch the videos. Let me know when you're done. Here, we'll start the video again. You are all here today, and I've got a video of another dog dish on there. I think I always like to talk about dog dishes in this example. And I think yeah. So V1 would be the blue equation, the whole volume of the shape. And then V2 would be this part if you did the whole volume of it. And I'd subtract that away to get my entire volume. So the integral of cos 2x is just sine 2x, and you'd have to divide by 2 because of the chain rule. Question is, do you need to know your pi plate, your unit circle for calculus? The answer is yes, because you get a question like this. You need to be able to calculate what is sine of pi over 2, what is sine of 0. Can I go that far? Is that okay? And we just get pi over 2, whatever your units are, how big this dish is that you would like, meters. Biggest dish in the world, meters cubed.